So for the first one, for the law of sine, does it matter if your calculator is in degree or radian?
So these angles are in degrees.
Okay.
So I would put your calculator in degree. Usually if it's radians, it's going to have a pi in it. It's like pi over 4, pi over 3, something like that.
So for what I got for B was 1, like rounded, but I'm pretty sure that's not right.
You got B equals 1?
Yes.
Okay, well, we'll go over it.
Okay.
Just in a little bit. So I think you guys are ready to go over it. So I'm going to stop screen sharing. Okay. Can you guys see my screen?
Yes.
Yes. Okay. So for the first one, I just wrote down the length of C equals 5. And then the angle of C, and that this indication is just angle, is 70 degrees. Angle of A is 30 degrees. Angle of B is 80 degrees. So we know that the law of sine is that the sine of, let's say the angle of, let's solve for A first. So that would be 30 degrees over, we'll say the length A is going to be equal to the sine of, and then let's use C because we know both those values. So that's going to be the sine of 70 degrees over 5. Okay. So at this point, it's just punching things into your calculator. But if we want to do a little bit of the algebra, we would move the A over here, and we can also divide by that. But basically, you can end up with an A equals 5, the sine of 30 over the sine of 70. Also, sorry for my terrible handwriting. Oh, sorry, Alyssa, did you have a question?
No.
Okay, sorry. So, sorry, I'm just getting out my calculator. So if you plug it into the calculator, you should get that A is equal to about 2.66. I think the unit was meters.
Gotcha. Okay. Yeah, it's been a minute or two since I've done this. I remember how to do this now. Okay.
Oh, okay, sweet. And then you would use a similar process for B, but I'm just going to show you that on the slides. So I'm going to move on to the law of cosines. So I just have like B, sorry. So I have, B equals 2, 6 equals 6.33. And then I have all the angles listed here. So what we're looking for is A. We know that A is going to be equal to the square root of B squared. So that's going to be 2 squared plus C squared. And minus 2 times 2, which is B, times 6.33, which is C. And then times the cosine, the angle of A, 110. And if you plug that in your calculator, you should end up with something like 7.26. So, here, let me write that down. So A equals 7.26.
Yeah, that's what I got.
Sweet. Okay, so any questions?
Nope, just definitely needed a rerun of it.
No problem. Okay, and then I had, this is the full answers. Okay, so next, I'm going to start going over a little bit about vectors. And vectors are some of the most important things, especially for Physics 121, because they're pretty much all that you're going to be using in Physics 121. Now, a vector, I don't know if you guys have ever seen the movie Despicable Me. There's a character and he calls himself Vector because he has both magnitude and direction. And it's supposed to be a joke, but that's actually the official definition of a vector, is that they have both a magnitude and a direction. And
That's kind of funny. I never thought about that.
yeah. And so the other way you can think of vectors is just like, they're just arrows, basically. But they're super convenient because we can kind of add them together and use them to represent kind of like the direction of force, or when you get, if you're doing electrical engineering, you go later on, you can use it for like electric fields or magnetic fields or any of that sort of stuff. But for now, just for the basics, I just kind of want to go over the two ways that you can add vectors together. And so the first method is called the head to tail or triangle. And basically you just take the tail of one vector and you just put it right at the head, which is like the arrow, and you just follow it to the new point. So it's kind of like you're just connecting them together. And then the other method, which I don't really prefer because it's a little bit more complicated, is called the parallelogram method, which is basically you just take the two vectors and you make a parallelogram out of them, and then you draw from the two corners of those that parallelogram. But that method's kind of, I don't know, I feel like it takes more steps. I feel like the head to tail method is a lot easier to understand.
I have a quick question about the parallelogram method.
Okay.
So you have the long diagonal on that, which is u plus b, and then you have like the short diagonal, right? Which is like, I don't know, can I annotate on the screen?
I think I have to give you permission. Just wait one second. Oh, yes, you can.
Okay, so like, what's that then?
Oh, the line you just drew?
Mm-hmm.
I'm trying to think. I don't think it's really anything.
All right.
Sorry.
It's all good. I was just wondering.
Okay. Yeah, so if you're doing vector subtraction, you kind of do the, it's kind of like being the same as adding a negative. So let's say you're doing u minus v. So instead of what you would do is you would take v and you would flip it around, right? It would be like negating it. And then you would do the head to tail method again, just adding them together. But since one's negative, it's the same thing as like subtraction. In fact, I might just show you real quick. When I stop screen sharing, you guys can see the paper a lot better, right?
Yes.
Okay, sweet. So like, for example, you have u and you have v. Actually, let me do a different v. Let me do one that's like this, v. All right, and you want to do u minus v. And we usually draw these little arrows, and that means vector, right? So I can take u as it is, but v, since it's a negative, what I would do is I would flip it around. So that would be like this. So that's like a negative v. All right? And then I would use that, and I would add it on to this using the head to tail method. Right? And then what I would do is you take the origin of the first vector and the head of the other one. You draw a new vector, and that's the vector you're looking for. That would be u minus v. I hope that wasn't too confusing.
So could you just technically just do u minus v in the first place? You're just physically demonstrating on how to do it?
Yeah, pretty much.
Oh, okay. Okay.
Yeah. So, and this is pretty helpful. So like, for example, let's say you have like a box in space, right? So there's no air, there's no gravity, and it's just floating in space. And then you put a force on that box going this direction, right? And let's say it's 3 newtons. Right. Well, someone else comes along and they put another force on that box. Let's say 5 newtons. But this force is in the downward direction. But you still have the 3 Newton force that's pushing it, let's say right. So what will happen is the total force vector is you would add these two together, right? So you have this new box. I should actually be drawing it in the middle. And it's going to be like 3 over and 5 down. So this would be your actual force vector, or we would call it net force vector, or your magnitude. So this is a convenient way of, understanding the direction of forces and how other things work. So any questions?
Nope.
I'm good here.
Sweet. Okay, so I think I have. Okay, so this is the other method I wanted to talk about. So sometimes vectors are given in this notation, right? And this is what we call component notation, I think. I might be getting that wrong. But basically, it's giving you the vector in the xy plane, right? So when you have that -2, 9, it means like -2x and up positive y, 9. And this one would be positive x and one in that direction, and then 1 in the positive y direction. Right. So if you want to calculate the sum of these two, you can just add the individual parts. Like, for example, so it was -2, 9. That was 1, 1, right? And we want to add these two together, right? Well, the nice thing you can do is you can just add the x component and add the y component. So then it could just be -2 plus 1, which is -1. And then 9 plus 1 is 10. Right. And that would be the new vector. Is that clear?
Very.
Sweet. So, okay. Yeah. So that's for that one. But then sometimes you're given vectors in the term of magnitude. All right, sorry. I didn't start. Okay. So you're given vectors in the term of magnitude. So you'll be given a vector, and you'll be told its length, which would be a in this picture. But it doesn't tell you how far in the x or in the y direction. But it will also give you the angle of that vector. And the angle is usually, not always, but most of the time, traditionally, the angle is from the positive x axis going upwards. So if it's 30 degrees, it's going to be 30 degrees above the positive x. If it's 270 degrees, it would wrap all the way down and it'd be in the negative y direction. But usually to solve a lot of problems, you need to know the x component and the y component. And so these two formula up on the screen, it kind of tells you how to get each chunk or each piece of the component. So you just take the magnitude, which in this case would be a, and for the y component, you just do the sine. And then for the x component, you're just doing the cosine. And that kind of gives you each part separately. So now I'm going to give you guys another practice problem. I think I'm going to give you guys a few minutes just to try it out on your own, and then we can go over it together.
I'm ready when you are.
I'm going to turn that over. Okay. So I'm going to... Okay. Okay, so it was... Oh, sure, didn't write down the numbers. But it was... The magnitude was 8, right? We'll call this one A. So the magnitude was 8 at an angle... Let's see, what was the angle again? 30. Okay.
Yes.
Angle of 30 degrees. And then we'll say this one's B.
And that was
Oh,
5.
this is VW. Oh, sorry. So 5 at angle
160.
160. Sweet. So in this case, you just plug them straight both into the calculator. And you would just basically, you know, for A's y component, we would have 8 times the sine of 30, right? Which I think is going to be 4.
I got 4.
Sweet. And then A's x component can be 8, the cosine of 30.
I got 6.92.
6.92. Okay. And we got B's y component. It's going to be, 5 times the sine of 30. Oh, no, sorry. 160. which I got 1.71.
Correct.
And then the x component, 5 times 6.
And then I got 4.7 for that.
4.75.
Yep.
Okay, so did you enter in cosine 160?
No.
Okay,
I forgot
so,
the y.
okay, so one of the things here is you want to make sure you enter in the actual angle because it's supposed to be negative 4.71. Wait, no.
It's going to
0.7.
be, yeah.
Yeah. Because
Right.
then that gives the like correct direction of the vector.
Gotcha. Okay.
Mhm. So then when we add all of these together, and I'll just say V plus W, since that's their actual names. You know, the Y component is going to be 5.71. And then the X component, sorry, just going to look at it real quick. It's going to be 2.22. Now the neat thing here is that we can actually use Pythagoras' theorem. I'm not gonna spell that actually, I don't know how to spell it. But you could just do 5.71 squared plus 2.22 squared. And that's gonna equal, we'll say the magnitude, and I'll just call it C squared.
And it should be 6.12.
6.12?
Yeah.
Sweet. Okay. And then to find the angle, you would just do the tangent inverse of the y length because we're doing opposite over adjacent. So that would be 2.22 over 5.7.
Can you scoot up the paper a little bit, please?
Oh, sorry.
You're fine. So you said C is the tangent? I'm sorry, not tangent, the magnitude?
Yes.
Okay.
So that would be the magnitude.
And then
Again, sorry for my terrible handwriting.
you're fine. It's easier than most.
So, and then the angle. So let me maybe draw this up. So this is like C. And we'll say, well, it's really called V and W. You know, and we have this angle. And we know, you know, the tangent of that angle is going to be equal to the opposite, you know, the length, right? And you use the absolute value sometimes to mean like magnitude. So we know that the angle is going to be equal to the tangent inverse of those magnitudes, which is 21.25 degrees. Any questions?
Nope.
Sweet. Okay.
I will say you helped with the magnitude because I understood how to get to magnitude. I just didn't know that C was automatically magnitude.
Oh, okay.
If that makes sense.
No problem. Okay. I keep jumping back and forth. Okay. Oh, yeah, so there's all. So I got 6 point. Oh, I made a mistake and wrote down the magnitude for the angle. But according, I think it should be 21.
It should be 21.25.
Yeah. Sorry about that. Okay, this one, I might skip this one because I think we've already gone over it, unless you guys want to go over it.
I'm
I'm good on
comfortable
it.
with skipping it.
Yeah, me too.
Okay, let's skip it then. Okay. So this is a little bit more complicated concept. And we're going to go over something called the dot product. Now, the dot product, it's kind of hard to explain exactly what it means, but it's kind of like the projection of a vector on another. But it's pretty easy to calculate. There's two different ways you can calculate it. So if you have a vector A and you have a vector B, the first way, as you see on this formula on here, by the way, we write the dot product as just writing a dot. So A dot B, and that means dot product. So the first way you can write it is the magnitudes of those two vectors times the cosine of the angle in between them. And the thing about the dot product is it's always going to be a scalar, meaning it's just a number. It's not a vector. So the other way you can calculate it is if you have the x and y components of each vector, you can just multiply each individual component times the other component, and then sum all of those values together. So for example, like here you have A1 and B1. So that would mean in this picture, A1 meaning A, the value of the x value of A, which would be -6 because it's in the negative direction. And then B1 would be the x component of B, which would be 5. And then A2 and B2 would be like the y components. And then sometimes you deal with three-dimensional graphs, especially when you get to like Calc 3. You'll start having z components. And if you go even farther, you can start 4 or 5 components. But for Physics 121, you only need to understand the 2 components. Any questions though about it?
Nope.
Okay. Okay, so here I have an example, right? So I've given you 2 vectors in just their component forms. So we have the x, y, z's, whatever the fourth one is. And so you have the 2 of them. So you can take each component and multiply it by each other and do that for every component and then just add them all together. So let me so it was -3. Oh, sorry. It was actually 9. 9, 5, -4, 2, -3, -2, 7, -1. So you can just multiply each element. So that would give us -27, -10, -28, and -2. All right. And then you can just add all of these together, which I think is going to give you
-67.
-67. Thank you. -67. So that is the dot product of these 2 vectors. Okay. So now we're going to move on to something a lot more complicated. So I don't know when you guys are going to take linear algebra, but you don't really need to know it for Physics 121. But, oh, sorry about that. My lights turned off. But one of the important concepts to understand is something called the cross product. Sorry, I just saw your comment. Okay. So one of the important things to understand is something called the cross product. And it's kind of weird because it's kind of like the dot product, but what you have in the end is not a scalar. It's going to be a vector. And there's this simple rule or kind of trick to figuring it out. And it's called the right-hand rule. And the right-hand rule is really easy. So you take your right hand and you kind of try and make where your index finger and your middle finger are like 90 degrees apart from each other. And your thumb is 90 degrees apart from both of them. And you kind of use your index finger to represent the first vector. And then you use your middle finger to represent the second vector. And then your thumb will be pointing in the direction of the cross product. And so this is a really simple trick. It's mostly just used to understand the direction of the cross product. And for Physics 121, that's really all you need to know. You don't really need to know how to fully calculate the cross product. And you'll learn that in linear algebra. But it's very helpful in understanding because it helps us understand how some forces relate to each other, especially when you get to Physics 2, when you start messing around with electronics. So here I have a problem. And so it's saying, you know, on a piece of paper, the first vector is pointing to the right of the page. And the second vector is pointing like into the page. So then the question is, what would be the cross product of these two vectors? So what do you think it would be?
Would it be pointing down?
I don't think so, because
like
so
if
the first
thumb wants to
vector.
go, okay,
Sorry.
no, go ahead.
Okay. So the first vector is like your index finger, right? And that's pointing right. And then your middle finger would be, actually I can show you on the camera. So it's like there. So it would be pointing right like this, right? And then your middle finger is pointing into the page, right? So if we're looking down on the page, we're seeing our thumb is pointing upwards.
I had that completely flipped.
Oh, no problems. There is something called the left-hand rule, which you should use for like if you have a negative value, but I would not recommend doing it. It just makes everything way more confusing.
Okay.
But yeah, it would be upwards.
Okay.
But I hope that makes it clear how to do it.
No, that makes sense. You showing me made sense.
Yeah.
I just had my entire hand flipped.
Oh, sorry.
I just had my entire hand flipped, so that's why.
No problem. I know, like in a electric motor, when you have like magnetic force and electronic force, or sorry, current, you know, the direction of the force that it will produce on the motor is the cross product of the magnetic field and the current running. And that's how electric motors work, is they purposely design it so that the current goes in a certain direction through a magnetic field, and it produces the force that turns the motor. That's just some trivia. You don't really need to know that, but okay. So the last thing I'm going to go over tonight is some basic calculus. And you might have already taken calculus, but sorry.
I have. I'm pretty familiar with it.
Okay, sweet. So for Physics 1 then, all you really need to understand is, you know, just basic derivatives. Very, very simple derivatives, particularly like power rule. So I guess just a little refreshers. As you know, as you move the r down, you subtract 1 from the exponential, right? And here's I don't know why the middle one's so blurry, but And here's a basic summary of what you would do. Okay, and then there's some more practice too. But the other thing I did want to go over is something that's particularly important also is to understand the derivatives of all the trigonometric functions. And these are things you really just memorize. You never really know how it actually works. So I would advise just making sure you have these written down and you have these on hand. It will save you a lot of time.
Okay.
Okay. Well, that's pretty much the end of what I had planned for tonight.
Okay.
If you have any questions or want to go over anything more specific, I can. I have my papers here, and we can do any problems or anything. But if you want to go, you're free to go.
Probably the only thing I would really have questions about is I'm having a little bit of a hard time understanding, like, basically the Ferris wheel problems. Like, if the Ferris wheel is moving like in a circular motion at like a certain speed, then like where is the person at like 10 seconds or something like that? Like, that's mainly what I'm having trouble with right now, but I don't know how adept you are.
Yeah, I can probably work on those. That kind of goes beyond the scope of what this review night was for.
That's what I'm
It was
saying.
just to teach like the pre stuff.
Okay, but other than that, the pre stuff makes sense. You're really good at explaining things.
Okay, sweet. But I'm in the tutoring center right now. So I don't mind staying and working through a problem or two just using the camera thing I have here. If you want to do that.
It's okay. I'm pretty sure they're going to have a review for the actual exam, and I'll probably ask it then. So.
Okay.
Thank you so much,
Do you know
though.
where tutoring place is located?
No. Can you tell me about that?
Okay, so there's multiple tutoring places, but the one that I'm working for is in the Tooker House.
Okay.
But there's also ECG 102, I think. They're open more during the daytime.
Okay.
But they would be more than happy to help you with any problems like that.
Yeah. The flyer had a room number on it. Is that the one that you're talking about? The THD
Yes.
101? Okay.
Well, where we do these workshops is 101, but we do the tutoring in 102.
Okay,
But
sounds
it's
good
right
then.
next door. So you'll see it if you come.
Alrighty. Thank you so much.
No problem.
You have a good rest of your night.
Thank you. So I'll go ahead and stop sharing.